So today we're going to do 7.4 and 7.5, similarity in right triangles. When you draw the altitude from the right angle to the hypotenuse of a right triangle, you actually divide that right triangle into 3 separate similar triangles. So ABC now becomes triangle ADC, CDB, and then the big triangle. So we make 3 triangles out of it, and they'll all be similar. This is 7.4, similarity in right triangles. It just says if we draw a altitude from the right triangle to the hypotenuse, we divide the triangle into 3 similar triangles. And we're going to prove that in just a second. Does anyone want me to pause so you can write that, or you don't really have to write it, but... So if you have a right triangle and you draw an altitude from the right angle to the hypotenuse, you make 3 similar right triangles. Here's the proof for that. It says that we have triangle ABC or ACB with the right triangle in this spot, like it's shown. And we want to prove that it makes 3 similar triangles. So first of all, why can I say ACB is a right angle? It's given. Why can I say CD is an altitude? Yeah, it says with altitude CD, so it's a given also. Why can I say CD is perpendicular to AB? How do I know it's a right triangle, though? It shows that, but how do I know if it didn't show it? What does altitude mean? Definition of altitude is it starts at a vertex and hits the opposite side at, yeah, or is perpendicular to opposite side. So step 3 is just the definition of altitude. Altitudes are perpendicular, start at a vertex at the other side at 90. Why can I say now that I know that that's perpendicular? Why can I say those 2 angles are right angles? Yeah, perpendicular lines meet at right angles, yep. So definition of perpendicular, perpendicular lines meet at right angles. ADC, angle ADC, so ADC, this angle, is congruent to ACB, this angle, and then CDB, this angle, is congruent to the other right angle. Those are all right angles, right? Why can I say all of those right angles are congruent? Because all right angles are congruent. That's the reason. Angle A is congruent to angle A. Angle B is congruent to angle B. Not transitive. Reflexive property. Then why can I say I have similar triangles there? What are our reasons for similar triangles that we learned last week? We had a few different ways we could prove similar triangles. One was what? Angle-angle similarity. Side-side-side similarity. And side-angle-side similarity. So yeah, we haven't talked about sides at all, so this has to be angle-angle similarity, right? Angle ACD. ACD, I'm going to erase these. So ACD is congruent to CDB. CD, oh, that's not what I want, right? ADC. Oh, because I wrote the wrong one. ADC. ADC, that's this one, right? Is congruent to CBD. CDB. That one. Again. Oh, sorry. No wonder why. Number 8, ACD, which I had, is congruent to angle B. Why can I say those are congruent? We already proved that the triangles are similar, right? If we have similar triangles, all the angles have to be not proportional. All the sides have to be proportional. All the angles have to be congruent, right? So in similar triangles, corresponding angles are congruent. And number 9, ADC is congruent to CDB, so ADC. Not the 2 triangles, but those are again right angles. And then, so now I have 2 more sets of angles, so why can I say those other 2 triangles are similar? We only have angles, so what's my reason for angle similarity? Or triangle similarity? Angle similarity. It's just angle similarity. So that's how you would prove that if you have a right triangle. Yeah, but we're supposed to prove the theorem before we use it, so that would be it. All right. So if we want to write a similarity statements what? What does that mean? We wrote congruency statements when we were talking about triangles are congruent. Similarity statement is just that triangle is similar to that triangle, which is similar to that triangle. In this case, if we start with x, y, z, x, y, z, which is the big triangle, it's going to be similar to what on the medium triangle? Let's just talk about what we went by. On this big triangle, is this a long leg, a short leg, or a hypotenuse? This is the short leg, this is the long leg, and this is the hypotenuse. So when we wrote our order, we went by the short, and then by the long, and then by the hypotenuse. So we had to do the same thing in the medium triangle. So in this medium triangle, if I want to go by the short, and then the long, and then the hypotenuse, I would write triangle W to Y, that's short. Is Y to Z the long or the hypotenuse in this medium triangle? Yeah, in this one it's going to be short, long, hypotenuse, right? So YW, that is not a Y. Y, WZ. Then let's look at the little teeny triangle. This one I want to go by short and then long also, right? So it's going to be XWY, right? So that is a similarity statement. We just have to write which triangles are similar to what triangles, and you have to make sure you do the order in the right order. So a lot of times when we're setting up these similar triangles, we end up with geometric means. And geometric means are just proportion where the means are equal. For any, well, if only we could see it, hold on. This should move, but cancel. Usually I can, it's just that it's out of range, I think. Okay, so if we want to do this one, it's proportions in which the means are equal, and they occur a lot in this section. For any 2 positive numbers a and b, geometric mean of a and b is a positive number x such that a over x equals x over b. So if you're asked to find the geometric mean and you're going to be given an a and a b, it's just a over x equals x over b. Oftentimes when you write up these geometric means and you're going to cross multiply, one of the cross parts are going to have the same thing. They'll either both have x's or they'll both have the same number. So in problem 2, we're given the number 6 and 15. So that's our a and our b. So I'm going to write what? 6 over x equals x over 15. We cross multiply, I get x times x, which is equals, I am just going to write 6 times 15. 6 times 15 is going to give me a big number. I'm going to have to then break it up, because if we want to solve x squared equals a number, what do I do to both sides? How do you get rid of squared? We take the square root of them, right? So I need to take the square root of both sides. So square root of x squared, the positive one, is just x, right? X equals, I am going to, instead of multiply 6 times 15 together. I'm going to start breaking them up because if we want to simplify a radical, we're looking for two things that are the same under the radical, right? So 6 I can break up into what two numbers? 3 times 2. 15 I would break up into times 5 times 3. Anytime you have two of the same things under the radical, what happens? One of them comes out, right? So I have these 3's. 2 of them are under, 1 comes out. Can I do anything with the 2 and the 5? There's no more pairs. I can't break them down anymore. So I'm just going to leave those under the radical and put them back together. So my answer would be B, which is 3 square roots of 10. Questions on doing that? All right, go ahead and try 4 and 18 on your own. You should make sure it's as simplified as it can get. You're just good. Yep. Make sure you simplify what's the number under the radical is as simplified as it can get. Yeah, you should have gotten, I saw some people do this, which is fine, and then you just have to break it up. Or you could have done equals square root of 4 times 18, which is 9 times 2. I prefer this way because I can then simplify. Square root of 4 is the number 2. Square root of 9 is the number times 3. Can I do anything with this square root of 2 that's left in there? So I get 2 times 2, which is 6 square roots of 2. Now, I could have broken that 4 down into 2 times 2 and the 9 down into 3 times 3 and pulled out, there's 2 under, I take 1 out. And you can do that if you want. We are randomly going to try a couple other geometric means. Give me some numbers. Let's try some. What? Got to be bigger than 6 and 4. Give us a little bit of challenge. 12 and 22 I hear. 12 over x equals x over 22. I'd have x squared equals square root of 12. Let's break 12 down into. I do 4 and 3 because I know 4 is the square root of 4 is 2. And then 22 would be 2 times 11. All right, I can pull out, I know the square root of 4 is 2. Can I do anything with the square root of 3? It doesn't have a pair. Can I break down square root of 2? It doesn't have a pair. Can I do anything with the 11? So I just multiply these 3 back together. And we get 60, yeah, square root of 66. Let's try another one. Give it 2 numbers again. And can we just agree it's going to be x squared equals whatever the numbers are times each other? Give it 2 numbers. 30. Give me another number. Not 36 because that is a perfect square. That's 6, right? 24. I know I take the square root of both sides. Let's break down 30. It's what? If I did 10 and 3, could I just do 2 times 5 times 3? That's 10, right? 2 times 5. And then 24 is going to break down into... I heard 12 times 2, but 12 would be 4 times 3 times. That's 12 times 2. Does that go? Is that, and you can always multiply this all, make sure it was right. What do we have? I can pull out a 2 there, right? I have a pair of 3's there. Square root of 4 is times 2, so that's gone. What's left in? And on the outside, I get 12 square roots of 5. Now, could we double check our answer by plugging that number in? 12 times square root of 5, and then plugging in square root of 30 times 24 and seeing if it's the same? Right, we could if you want to double check, right? So you're welcome to check your work, right? You can check it. Let's move on. Hey, there are a lot of really confusing looking corollaries in here. I don't like them. So we're not going to take the time, but it's showing that we use a lot of geometric means in this. You can feel free to look at them if you want later on. We're moving on. All that those corollaries do is tell us how to set up proportions, and we're just going to put similar parts over similar parts. I have 3 parts of a right triangle. I have the short leg, I have the long leg, and I have the hypotenuse. And if we draw this altitude in right here, I will tell you this because sometimes you can't tell. On the small triangle, it's going to be the long leg. On the medium triangle, it's going to be the short leg. So I'm going to redraw my triangle. Here's my little triangle. This is a 4 and an X, right? The medium triangle, that's a really bad right triangle, but this is 12 and Y. This is Y here too, isn't it? In the small triangle, we have a Y here. And then we have the big triangle. What's the length of the hypotenuse of the big triangle? 16. Segment addition postulate says I can add that 12 and that 4 together and get a 16. And I have X. Do I have this part of that triangle at all, the long leg? So this would be long leg, short leg, so on this one I have the short leg and the hypotenuse, right? And on the green one we have the short leg. And it's with it. This is the long leg. And on the little tiny triangle, 4 is the short leg, Y is the long leg, and this is the hypotenuse. All right, we're just setting up similar parts. So we are going to start by solving X. I know in the little tiny triangle, X is the hypotenuse. I don't want X and Y in the same problem. So in the small triangle, I have the hypotenuse, which is X, and the short leg, which is 4. I'm going to look for another triangle that I have hypotenuse and short leg. So do I have that in this triangle? In the blue triangle? Yes. Do I have it in the green triangle? I don't have the hypotenuse, right? So I'm using the small or the red triangle and the blue triangle. So if I start with the red triangle, 4 is the short leg. I'm going to go to the blue triangle and I want the same side. So what's the short leg in the blue triangle? X equals, go back to the red triangle. We have the hypotenuse, which is, hypotenuse, the one across from the 90, which is X. And on the blue triangle, we have the hypotenuse, which is 16. Now here's where we're talking about geometric means, is often you have x's across from each other, or 2 numbers that are the same across from each other. If I cross multiply here, I'd get x squared equals square root of 4 times 16. What's the square root of 4? What's the square root of 16? So 2 times 4, which is x equals 8. Now we're going to go to do y. So if I look at y is in the green triangle, which is medium. So in the medium triangle, we have the short and the long leg. So now I need another triangle with a short and the long leg. Which other one do I have with short and long? Red or blue? Which one has short and long? I hear red. So we're going to do red and green. I look for, so in the green triangle, we have the long leg and the short leg. In the red triangle, we also have the long leg, which is y, and the short leg, which is 4. So if we start in the green triangle, let's start with 12. 12 is the long leg. So in the red triangle, I need to put it over y. Y is the long leg in the red triangle. Go back to the green triangle. We started with 12. We now will put in y, which is the short leg, over short leg in the red triangle, which is 4. We get y squared equals square root of 4 times 3 times 4. Right, 4 times 3 is 12. So I did 12 times 4, but 12 is 4 times 3. I have a pair under, so I can take one out. So what am I going to pull out of this? So I have y equals 4. Can I do anything with the 3 that's left in there? So 4 square roots of 3. Questions on those? So again, we're deciding similar parts over similar parts. I'm going to let you do this one on your, or get started on your own. So let me see if I can make it bigger. All right, there you go. Redraw the triangles. Start by redrawing the triangles. Solve and get x and y. All right, I know said by yourselves, but let's come together in a second. Let's see, worry about x. So x is going to be, if I look at this little triangle, sorry, I forgot to draw my right angles in there. The small triangle, I have x, which is the, what part of x is the small triangle? What part of the small triangle is x? Hypotenuse. And I don't want to put x and y in the same problem, so I have the hypotenuse, and what is the 4 on that little triangle? Okay, so I have hypotenuse and short leg. So I'm going to write up relations between hypotenuse and short leg. So when I do that, if I start with hypotenuse of the little triangle, I need to find another triangle that I have hypotenuse and short leg on. Which would it be? Do I have it on the medium, the hypotenuse? Nope. I have it on the big one, and I wrote the hypotenuse as 9. How to get that 9? Yeah, it's 5 plus 4. We can do segment addition postulate. That's just like an add 2 smaller segments to make up a bigger one. So if I did hypotenuse of the little triangle, I'm going to put it over hypotenuse of the big triangle, which would be the 9. I have to go back to the small triangle. I started with the hypotenuse. I'm going to now go to the short side. Excuse me, I did hypotenuse. It should be short over short, right? Hypotenuse over hypotenuse equals short over short, sorry. We did hypotenuse of the small over hypotenuse of the big equals short of the small, which is, what's the short side of the small triangle? 4 over short side of the small, the big triangle, which is, oh, hypotenuse is 9 on the big triangle. So if I cross multiply, I'd get x squared equals, okay, 36. What's the square root of 36? So x is 6, right? We have to solve y, right? So y is in the little triangle, and in the little triangle, so then I have y is the short leg, long leg, or hypotenuse of the little one. Long of the little triangle, so I have long and short in the little triangle. Find another triangle with long and short. Which one do I have? What, the green one, the medium one, right? So I'm going to do small and medium. So I need blue. So if I start with short over short, I want to set equal to long over long. So short of the blue triangle is what side? So 4 over short of the green triangle, which is y, equals, go back to the small triangle, and I need long. Long is y over long in the other triangle, which is 5. So cross multiply, I get y squared equals square root of 5 times 4. What do I know about square root of 4? Sorry, y equals 2 square roots of 5. So again, we're just setting similar parts over similar parts. Now, could we have done, if we did short over long of the small triangle, short over long would have been 4 over y, right? Could we set that equal to short over long of the medium triangle? Short is y over long, which is, would that be the same when we cross multiply? You just remember I always said you have to follow a pattern. You have to follow a pattern. If you do short over long equals short over long, that's okay. If we did short over short equals long over long, that's okay. You just have to follow a pattern. So here is a real life problem. If you are preparing for a robotics competition using the setup shown here, A, B, and C are located so that AB is 20, which it's marked here. So this is 20 inches. We know that AB is perpendicular to BC, so they drop to altitude down at point B. DC, this part is 9. And we want to find how far it is from A to D. How far does the robot have to travel? So we are going to set up proportions again. Which two triangles are we going to use? If we look at this triangle, do I have two bits of information in that triangle, or do I just have one thing that I know? I know this is 9. Do I know this? Do I know anything about this? It's not even represented with a letter, so I know that triangle is out. So I'm going to go with the entire triangle and this medium triangle. If I redraw the medium triangle, we know this is x, this is 20. If we redraw the entire triangle, I know this is 20. What's this length of the hypotenuse of the entire triangle? Is it 9x? X plus 9 or 9 plus x, either one. You have to do a segment addition postulate so as I can add those two, the 9 and the x together. Oftentimes, once we put a variable in there, people want to say times, like 9x, but it's not. It's x plus 9 or 9 plus x. All right, so again, we're going to put similar parts over similar parts. In this triangle, the 20 in blue is the long, short, or hypotenuse? Long. And this is the hypotenuse. And in this triangle, I have 20 is the hypotenuse. X is the... Somebody give me a thing to start. Give me a proportion. What over what? X over 20. X from the green triangle, which is the long leg, over 20, the long leg in the medium triangle, equals, we have to go back to the green triangle. So on the top is going to be 20, and on the bottom in blue will be, yeah, if we start with the green triangle on the top, we have to start with the green triangle on the bottom. So this one, when we cross multiply, here the 20s are together, right? So 20 times 20 is 400 equals x times x plus 9. You get 400 equals x times x is x squared plus, how do we solve these? We did do it last week. I hear subtract 400. I do my mathematician stuff. So I get 0 equals x squared plus 9x minus 400. We have to, magic word starts with an F factor. We're not foiling, we're factoring. I know two things multiply together to give me negative 400, but I have to add together to give me, ooh, nope, plus 9, yeah, 9x. Multiply together to give me 400, negative 400, this number, multiply together to give me that number, but add together to give me this 9x, or 9. So I know 20 times 20 is 400, so I know one's going to be smaller than 20, one's going to be larger. So take 400 and divide it by 18, for example, 16, 14, 15, till you find two numbers. 16 and 25, are they 9 apart? Do they multiply together to give you 400? Then they work. I want, which one do I want to have the negative sign in it, the 25 or the 16? The 16, why? Yeah, when I do this, that's a negative 16x, and this would be positive 25x, and I want to end up with positive 9 in the middle, right? So this is it. Hey, how do I solve this if they multiply together to equal 0? I set each of those sets equal to 0 and solve, so I'd do x plus 25 equals 0. Or x minus 16 equals 0. So yeah, our answers are going to be x is either negative 25, excuse me, and x is positive 16. Which one of those is possible? It has to be 16 in this case because we're talking about the distance something traveled, right? So it can't travel in a negative 25. You can't have a negative distance, so it's got to be 16 inches. So that robot traveled 16 inches. Questions on 7.4. We're moving on to 7.5. Proportions in triangles. So these are when we don't necessarily have a right triangle, but the first one's called side splitter theorem. And the side splitter theorem says if you have a parallel line inside of a triangle, that line is going to divide the other side up, the sides up proportionally, or in math terms, if a line is parallel to one side of a triangle and intersects the other two sides, it divides those sides proportionately. If a line is parallel to one side of a triangle and intersects the other two, it divides those sides proportionally. So once again, side splitter theorem says if a line is parallel to one side of the triangle and intersects the other two, it divides those sides proportionally. Tacos always sound really good. All right. So this says on this picture, XR, that part, over RQ, that part, equals SY over SQ. So they're saying the little part over the little part. What I tell kids is side splitter theorem literally makes, if you extend the parallel line, it makes your two fractions. So you're going to have this, let's see, A over B. If this was A, B, C, and D, it'd just be A over B equals C over D. It just breaks that parallel line, draws in your two fractions. So it's top over bottom equals top over bottom. So we're going to prove the side splitter theorem. So they're giving us a triangle QXR with this parallel line running through it. So they're giving us the first thing, the two lines are parallel, that's just given, right? Why can I say angle 1 and 3 are congruent and 2 and 4 are congruent? Why do I know 1 and 3 and 2 and 4 are congruent? Yeah, when you have parallel lines, corresponding angles are congruent, right? When lines are parallel, corresponding angles are congruent. That could also be called corresponding angles theorem or postulate, corresponding angles. Now, why do I know those two triangles are similar then? That top triangle, the little one, and then the whole triangle. How do I know those are similar? We haven't talked about sides at all, right? So what's our similarity that does not have sides? It's got to be angle-angle similarity. We haven't talked about sides. We've only talked about angles. Angle-angle similarity. Then they're writing up this ratio, XQ. So step 4 says this side of the big triangle over RQ, the side of the little triangle, equals this side of the big triangle over this side of the little triangle. Why can we say that? We can't use side splitter theorem to prove side splitter theorem, but we're not actually talking about side splitter theorem because we're talking about whole triangles. So I'm talking in the big triangle where we know that this is 1 and 2. I know this is QR in the big triangle, Y. In the little triangle, I have QRS. So why can I say that QR, the left side of the big triangle, over, I wrote one of them wrong, sorry, QX. Why can I say QX or XQ? So the left side of the big triangle over the left side of the little triangle is equal to the right side of the big triangle over the right side of the little triangle. If we know the triangles are similar, why can I say I can write up proportions? Because if triangles are similar, sides are proportional, right? If triangles, similar triangles, sides are proportional. And similar triangles, sides are proportional. All right, now why can they say side XQ is made up of XR plus RQ? So why can I say XQ is made up of XR plus RQ? Yeah, but what theorem is that? Segment addition postulate, right? So these are both going to be segment addition postulate. How can I go from step 5 to step 6? Actually, it's 4 and 5. From 4 and 5 to 6. Not transitive. I would call this transitive in this case. What's the other thing that we use instead of transitive? Substitution. Yeah, so we're taking out this XQ and replacing it with this, right? So this is just substitution. Now this last step, they are going to say property of proportions number 3, but we're going to show how that works. Yeah, exactly. So, you know how when you're adding, let's say if we had 2/3 plus 5/12. What do I have to do to add those two? Common denominator, right? So what would be my common denominator? Oh, I don't want to do. Okay. Sure. So how do I get 2/3 to be 12? So I have to multiply top and bottom by 4, so I get 8/12 plus 5/12, right? Because that already is in 12ths. Could I rewrite that as 8 plus 5 over 12? Right, and that is 8 and 5 is 13/12. We're kind of doing that. So if we look, how we get to step 7, if I take step 6 and I have this over RQ, can I take step 6 and break it up to be, isn't that kind of what we just did in reverse? We took 2 that were separate and wrote them together as 1. So can I take 1 and write them together as 2 separate? Yeah, that works, right? So that's number 6. It's just rewritten as 2 separate fractions on the left. And I'm going to do the same thing on the right. I'm doing ys over sq plus what? Sq over, what do I know about RQ over RQ? That's just 1, right? So I have this plus 1 equals ys over sq plus what? Plus 1. Then mathematically we can, how do I get rid of those 1s? Subtract 1 from both sides. And then we get that x r over rq equals ys over sq, which is what we're trying to get at the end, right? That's exactly what we want for our step 3. So what they call it, something proportions, whatever. You're not going to have to do it on the test, but that is how we do the proof for this side splitter theorem. It's just a proof for the side splitter theorem. We just worked it out. So we can use the side splitter theorem. Remember I said that parallel line makes your 2 fractions? So literally I have that fraction and that fraction. So I'm going to write 12 over x plus 1 equals what? That's all I have to do. Cross multiply here, I'd have 12 times x equals 9 times x plus 1, right? So I have 12x equals, subtract 9x, I have 3x equals 9, so x is 3. That's all I have to do for a side splitter theorem. Literally, you just split the sides up into 2 fractions and set them equal to each other. Same thing works if you have another parallel line drawn in there. So instead of 2, we now have 3. We don't have the top of our triangle. It does the same thing. It's saying if 3 parallel lines intersect 2 transversal, the segments intercepted are proportional. So again, this proportion over this proportion would equal that over that. So we're just still breaking it into 2 fractions by extending the parallel lines. So in this case it says 3 campsites are shown in the diagram. What's the length of site A along the river? So I want this, I'm going to call it X. This says this is 9 yards. This is 7.2, 8, 6.4, and this just says site C. So how do I find X? Extend my parallel line, give me 2 fractions. I'm going to do X over 8 equals, extend my parallel lines, 7.2, 9 times 8. 72 equals 7.2x, so x has to be 10. Now it says, what if we were camping at campsite C? Sorry, 9, 7.2, 8, 6.4, C. Extend this one. And what am I going to write? What over what? 8 over 6.4 equals 7.2 over C. Could we have written C over 7.2 equals 6.4 over 8? Same thing. Cross multiply here, I get 8. C equals, I don't know what that number is. What's 7.2 times 6.4? 0.08. I thought you said, oh, wait. And then divide by 8 and you get C equals 5.76. So if you want to find the site that's the biggest, you could figure it out, right? Questions on side splitter theorem? If you need to get up and walk, you're welcome to. It's hot, getting warm in here, so if somebody needs to get up and walk to stay awake, you're welcome to. Here's the very last theorem, then we're good for work time. This is called triangle angle bisector theorem. Not a right triangle, but if an angle is bisected, so if a ray bisects an angle of a triangle, it divides the opposite side into two segments that are proportional. So if you have a ray bisecting an angle in a triangle, it divides the opposite side into two proportional sides. If a ray bisects an angle of a triangle, it divides the opposite side into two segments that are proportional to the other two sides of the triangle. This is one where I just think of put similar parts over similar parts. It's kind of like we did long, short, and hypotenuse. Same idea. We're just going to put the similar parts over similar parts. So in the theorem that they have drawn out, they say CD, which is one side of the bisected opposite side. So CD, the opposite side, over DB, the opposite side, equals the bisected angle side over the bisected angle side. So we're putting similar sides over each other again. So in problem 3, if according to this, if we started with CD up there, we'd start with what on here? Like either the 10 or the 18, right? We're doing the opposite side over opposite side, so it'd be over 18 equals, I have to go back to the triangle that I started with, so I started with the triangle with a 10. So 12 over x. They're just similar parts of two triangles, right? So opposite over opposite equals side that's not opposite over side that's not opposite. 10x equals 18 times 12? 216. So x is going to be 21.6. So that is the very last thing, triangle angle bisector theorem. And do you want to do another one? Everybody? Wait, did you say yes? Okay. Okay, what would you set it up? So if we did opposite side, 9.6, we won't finish it over. What's the opposite side? 16 equals, go back to the 9.6 triangle. Y over 24, cross multiply. Here's what we're doing today. We are doing right triangle similarity worksheet, which is in that packet you already have if you have the packet. If not, I have it in my drawer back there. It says CUDA right triangle similarity, I believe. It's front and back in your packet. And Math Excel. Let's talk a little bit about Math Excel, so stay sitting. In Math Excel, if you want to go back in and improve your score, you click on the assignment and there's two buttons on the bottom. One is like review and the other one is improve my score. You have to click improve my score or you're not going to have those, it won't let you enter things. So you can do improve my score. You can always improve your score. You should always be able to get 100% on Math Excel, because if you get one wrong, all you have to do is hit similar exercise. It will let you do another problem that's similar until you get it right. It doesn't show me how many times you got it wrong. You can have it wrong 10 times. It just gives me your end result. So if you ended up getting it right the 10th time, it would just show me that you got the problem right. So you should always be able to get 100% on Math Excel. If I've already entered the Math Excel grade into the grade book and you go back and improve your score, which you're allowed to, I won't know to check it. So if it's already entered into the grade book and you went and did it late, send me an email saying, Mrs. Carlson, please change my Math Excel 7.4 assignment or something so I know to do it. Okay, otherwise, again, tomorrow for you guys is work day if you're not testing during this block. But, all right, go ahead and grab your stuff.